Efficient flower text entry in virtual reality. Text entry is an important task for many virtual reality applications. There are some challenges for users to type the text when wearing VR HMDs. As the most common VR interaction device, the handle controller is a good candidate input device for text entry. Here are the state-of-the-art handle-based methods for text entry in VR. However, in terms of typing speed, there is still a gap between the existing handle-based text entry techniques and using a physical keyboard in reality. In this paper, we proposed flower text entry, an efficient single-hand text entry technique based on a flower-shaped keyboard. In terms of layout design, it was a hybrid of the QWERTY and circular keyboard. We divided the QWERTY keyboard into 6 parts. Rotated the upper 2 parts upward. Rotated the lower 2 parts downward. And then placed the space key in the center of the middle 2 parts. Finally, a flower-shaped keyboard was formed. In terms of interaction design, we used 3D hand translation interaction for selection. The left part shows the interactive coordinate system. A user is moving the handle during text entry. The length of the blue vector represents the hand translation distance, and the orange vector is the projected hand translation vector which represents the hand translation direction. The right part shows the valid selection area of the keyboard. The green dot is the map position of the handle. We designed Pilot User Study 1 to evaluate 2 letter layouts, the alphabetical order, and the QWERTY, and 4 optimization options on our flower text entry. The first column was the default design. The first option was colored keys. We used 3 different colors to highlight the keys according to the letter frequency in English. The second option was mapped hand position visualization. We used a green point to show the exact position of the user's hand. The third option was word prediction and correction. We predicted the subsequent letters in the word based on the letters that the user has entered, which can also automatically correct spelling errors. The fourth option was audio and tactile feedback. We designed different sounds for key selection and backspace. Tactile feedback refers to the vibration of the handle when switching candidate letter keys. The results showed that the QWERTY letter layout and all optimization options significantly improved typing speed and reduced the workload. Of these options, Option 1 and Option 2 were both related to the visual feedback, and Option 2 performed better. Additional experiments showed that compared to using Option 2 alone, combining them achieved significant improvement of text entry speed without significantly affecting workload and error rates. So we finally chose the QWERTY letter layout and all optimization options. We designed Pilot User Study 2 to optimize the mapping. We tested the typing performance of 5 different linear mapping coefficients, and we also collected click points when participants clicked keys. We found when k equals 4.5, the typing speed was the highest and the error rates were the lowest. Then we analyzed the distribution of the click points of k equals 4.5. We found that the center of the keyboard moved from origin O to O prime. Therefore, we recalculated the mapping coefficients for each key. Interestingly, the k values of keys around the center of the keyboard were all less than 4.5, while k values of keys outside this range were all greater than or equal to 4.5. Thus, we use a piecewise mapping in each direction. Experimental results showed that the piecewise mapping improved typing speed significantly and reduced error rates compared to setting the k value with a constant value for all directions. So we used the optimized mapping in the following user study. We conducted a 6-day user study to evaluate the performance of flower text entry. In the last day, the typing speed of the novice group reached 17.65 WPM, increased by 96.99%, and the typing speed of the potential expert group reached 22.97 WPM, increased by 23.56%. The fastest speed was achieved by a participant from the potential expert group in the 6th day, reaching 30.80 WPM. In terms of accuracy, both answer and TAR were low, with 0.09% and 2.50% for the novice group and 0.04% and 3.42% for the potential expert group. We proposed flower text entry, which has been proved to be efficient, accurate, and easy to learn for users.